As a summary, what we talked about is show me, if you want to see if it's a parallelogram, show me both pairs of opposite sides are parallel. Show me both pairs of opposite sides are congruent. You could show one pair of opposite angles are congruent. Both pairs of opposite angles are congruent, I'm sorry. Show me the diagonals bisect each other, or show me that a pair of opposite sides are both parallel and congruent. We're going to use that to prove a quadrilateral is a parallelogram. You can pick any of those 5. Sometimes the question I'll ask you is, I'll tell you how I want you to do it. That's how it looks at in example 5. We have quadrilateral QRST, and I've graphed them for you. I want you to determine whether the quadrilateral is a parallelogram. We're going to justify our answer by using the slope formula. Now, how is slope going to show it's a parallelogram? Well, let's show you. Let's take a look at why. So first, let's start with QR. So I'm going to use Q and R. So our slope formula, remember, is y2 minus y1 over x2 minus x1. We should have that memorized by now. So I always like to use the second point, so I'm going to use 1. I'm going to say 1 minus 3. Remember, we subtract the y's, not in the same ordered pair. 1 minus 3 over 3 minus a negative 1. Well, 1 minus 3 is negative 2. 3 minus a negative 1 is 4. So the slope of QR is negative 1/2. Now let's turn around and let's do the slope of RS. So y2 minus y1, I'm not going to write it down for this one. It's written right there. So I'm going to erase Q, and I'm going to look at R and S. So now subtract our y's. So negative 3 minus 1 over 2 minus 3. Negative 3 minus 1 is negative 4. 2 minus 3 is negative 1. And negative divided by negative is a positive, so we get 4. Next, let's take a look at S to T. So we're going to say negative 1 minus a negative 3 all over negative 2 minus 2. So negative 1 plus 3 is 2. Negative 2 minus 2 is negative 4, so you get negative 1/2. Last, let's do Q to T, or T to Q, depending on how you look at that. So we're going to go T to Q. Back to the beginning. So negative 1 minus 3 over negative 2 minus a negative 1. Well, negative 1 minus 3 is negative 4. Negative 2 plus 1 is negative 1. So we get 4. Now, how does this show it's a parallelogram? Because remember what we talked about before, when we have same slope, it makes them parallel. Notice that QR and ST have the same slope. So QR is parallel to ST. And also notice that RS and TQ have the same slope, so we know RS is parallel to TQ. We've got a quadrilateral with both pairs of opposite sides parallel. That's what we've proved here. So we would say The reason that this is a parallelogram is the definition of a parallelogram, which I'm going to write that down. Definition of a parallelogram. When I say definition of a parallelogram, we're saying both pairs of opposite sides are parallel. If you want to write both sets of opposite sides are parallel, you could. This is a proof. It's a proof. It's a coordinate proof, so you're going to show your work, really. You don't have to write 2 columns and do all those reasons, but you're showing your work. That's what you're going to be doing when we do proofs in this lesson.